Welcome to the Tom Nelson Podcast. I think this is podcast number 150, and my guest today is Geoff Price, and I want to sincerely thank Geoff for doing this. This one's going to be a debate. We're going to talk about climate for maybe the next 60 to 90 minutes, and I think this is very healthy that Geoff has agreed to do this, so let's go ahead and do this. Geoff, you want to introduce yourself very briefly before we kick it off? Or?
Sure. Yeah, my name's Geoff Price. I've been I think I got into this topic originally. I had an uncle who was very conservative, and I recall him just at a wedding pulling me aside and saying, we're really going to have to keep an eye on this climate thing because they're going to have the scientists on their side. And I remember thinking what does that even mean? And why are the scientists on their side? And it just seemed like this interesting problem. And so I just got more and more interested in it over time, both in the interesting scientific puzzles it provides, and then also the debate and sort of checking things that I would find online and looking into them. Personally, I live in Seattle. I am formerly at Microsoft and Stripe tech companies. I originally, my degrees were in computer science and mathematical sciences. So some background in sciences from learning, but no active work and research or anything like that in the climate area. So I am just a citizen researcher, so to speak, and have always enjoyed sort of connecting with people and having the debate. I like debate and just sort of trying to reason out what can we know and not know about hard problems, and really appreciate you doing this and having me on. And so look forward to talking about this.
Okay, I would like to just maybe start with a question that why should a rational person believe that right now the Earth is too hot?
Too hot, yeah.
Yes.
I think that's a fair question about how do we know what the impact of warming is? And then so I think other than stepping back and trying to make some absolute statement about temperature, what the perspective is look, we have both ecosystems and civilization that has adapted over time to a relatively geologically stable climate that we, from what we can tell through the history of civilization, and through the ecosystems we understand it, they adapt as tightly as they can to a given climate range. And so when you warm rapidly out of that systematically, the impacts tend, lean to be more negative than positive. So, and that's been part of this debate since, Arrhenius in 1897 made, sort of the first prediction of AGW, was that he thought, maybe it'll make the world more balmy. He's living in the Nordic countries. From his point of view, it sounds pretty good. But learning about biology and ecosystems and lots of other things over time, came to more of a conclusion. We don't really know all the costs and the destruction that comes from warming. So of course it has a lot more to do with the pace of things over, if you give it another thousands of years, the Earth we fully expect will adapt to new temperature. But we're in an era where humans dominate a lot of things, including use of the surface. And so the consequences of warming at this pace really, at some point you can lay out checks and balances and say, why would we do, we don't even know all the snowball effects of damages that come from warming like this. And we can already see some pretty significant ones. And so the rational thing is to step back and say, why are we literally heating the surface of our own planet? Like, is that a thing a sensible species ought to be doing and being cavalier about, right?
So do you agree that generally in the past, maybe every time in the past, warm periods have been known as optimums and humans have done better in warm periods? And also that humans are a tropical species and we tend to like to live in warm places, that not many people live in northern Canada. When people retire or vacation, they go to warm places. Warmth tends to be attractive for humans. So the global average temperature is maybe 59 degrees Fahrenheit. I think the warming since 1850 has been beneficial. It's been good for humans and life on Earth. But do you disagree with any or all of that?
Well, I think you have a large, I think the thing that studies say about, for example, human mortality is that while currently, there's many more cold, it's very a lot of these problems are fun to debate because there's very complex data sources involved, and it's very hard to get clean data on, what is a heat mortality death, et cetera. So there's a lot to dig into in those kinds of studies. But overall, the picture is that there's more, currently there's more cold mortality than heat mortality. But we have a very large population clustered near the tropics, particularly in Southeast Asia, that currently doesn't have a ton of air conditioning and other defenses against extreme heat deployed. And so you do have human impact to heat at that level. You do get to temperatures where people just can't sort of function, particularly, you get closer to the tropics and the heat. It's sort of similar to the argument with coral, right? People like to say, hey, coral love the tropics, so they must love warmth, but objectively they're dying. So death is not a very good indicator of loving something, right?
Okay, I got some more feedback though. I'm looking at data right now that says even in places that we think of as warm places like Africa, Asia, or India, even there, cold kills way more people than warmth does. So even in those places, the warmth is not a bad thing, I would say. And as far as coral, you're aware that the Great Barrier Reef has just hit a record high in Australia? And this whole idea that the warmth has been bad for the Great Barrier Reef. I had Peter Ridd on here talking about it. It's not. I think he said, and I would agree, that bleaching has occurred and forever, basically, in the Great Barrier Reef. And it's not like it's a new thing. And there's nothing wrong with the Great Barrier Reef. It's doing just fine. And if the Earth warms a little more, we'll get coral in maybe some places where it's too cold for coral to form right now.
I think one of the things I think we probably can both agree that regardless of what we all say here, there's an objective world out there and things are going to happen, right? And so you can create all kinds of narratives, and a lot of, I would say, the climate debate occurs in, a little bit adjacent alternative realities where there's just a lot of stories that have been built up, an amazing number of stories. That's why, I like to tell people that I'm not sure that anybody has created as much lore on a topic as humans have created so much lore on the topic of climate that you can go out on the internet and find pretty much any number of Earths described by the lore that has been created. And so, I think it's useful to step back and say, for yourself, like, I kind of think of myself as a skeptic approaching these topics. And so when I hear these stories, it immediately, as a skeptic, it strikes a flag. Like, you're describing a situation for coral that, as far as I know, none of the major coral biology organizations, none of the major publishing scientists on studying these behaviors in coral, which Peter Ridd isn't, a lot of times the names, and you see this one name, right? You see Peter Ridd on all the media, all the interviews. He's this one guy, and so there's a method of choosing scientists to hear from, right? And you could say, hey, I'm going to go look at who's the publishing scientists that have done the most, have rolled up their sleeves and done the most on this topic. And that list is not the people that, we're going to quote when we have this debate. It's Peter Ridd, because we found a guy who says, hey, everything's fine, right? But you can kind of predict in advance you'll be able to find those people. So is it really adding any information to find that guy and have him say he thinks it's fine? What is the, where's the research? How does that support that?
So hold on. So you think that the great...
Let me just ask you, what do you think when biologists wave these flags about the Great Barrier Reef and say that the hugest threat to it is climate change and it's having, it's degraded from what it was, what do you think they're saying? And do you think you could reflect that the way that biologists say the story? Do you think you have listened to them and have heard that? And could you even if you don't agree with it, could you articulate what do biologists say about Great Barrier Reef?
I have heard them. I've listened to them a ton. And that's one thing. I think skeptics in general tend to be exposed to arguments on the other side more than alarmists do. I read their books. I watch the movies. I read their Twitter feeds and their blogs. I'm constantly reading stuff from the other side.
So summarize it for me.
Constantly.
What is happening to the Great Barrier Reef from their perspective?
It's bleaching. It's getting so warm that the coral is suffering, and these bleaching events are horrible. You fly over, and the bleaching is way worse probably than ever. It's just it's kind of it's a cataclysm out there. That's the narrative.
Specifically dead, right? Specifically coral dying by the thousands of miles.
Yep.
Right.
That is a narrative, and I do not believe.
Well, that's a narrative. You don't believe that actual death is happening.
No, I believe bleaching is happening, but I believe it has always happened. And I believe the Great Barrier Reef just reached a record high. It's doing just fine.
Well, we can come to that. We can come to that to the regrowth question. But I think it's interesting, like, because the core of it, from a biologist's perspective, is the mass death, right? Like, we know that coral as individual species live hundreds of years. That's one of the famous things about them. So when you build these rich ecosystems, they're incredibly rich coral environments where the individual species have developed this size over hundreds of years. And so the idea that it all dies off every couple of years is part of this alternative narrative world, right? Like you wouldn't sit in a coral biology class and have people say, well, most coral dies off every couple of years and grows back. That's not the reality of coral. So this question of whether it is dying or not that you're not sure of is pretty significant. And of course, and when in Australia in the Great Barrier Reef, when they have done studies on the bleaching happening, they go do dives in like 50, 60 locations. They ground truth, they dive, they ground truth what they're seeing from sensors and from photography with the story they see in the dive, and they're finding dead coral, right? And you can reproduce that death in a lab. If you heat up coral in water, it'll bleach, and then long enough it'll die. So it doesn't always die if it's bleaching, but you let it cook long enough, it absolutely dies because it's essentially suffocating. So I think that's a critical point of, is that real or not? Is this actually happening or not?
No, it's happening. Bleaching does happen, but have they ground truthed against what happened 1,000 years ago or way before Henry Ford was born? How do we know this wasn't happening then? I think it was. It clearly was. It was way warmer then. Well, why do we still even have coral? It was way warmer back then. Coral made it through somehow. Back 4,000 years ago is much warmer. 130,000 years ago, much warmer.
No, I mean, there's actually research on this. If you go to the even I think in the last interglacial, maybe it's the previous one. I could look it up, but there is evidence of coral moving quite significantly away from the equator because of the increased heat, which is sort of consistent with what we're seeing now. Like the climate, in general, that's the context with climate change, is that when you heat the surface of your entire planet, you don't necessarily know how it's going to affect the way all the currents and things swirl around, but you're definitely in general, and you maybe scramble out even more. So in general, average climates, they're shifting out of the zone that the species currently there are used to. So this just the Great Barrier Reef may no longer be a location that really supports coral reef in the long run.
Hold on. Are you aware of this?
We can come back to the regrowth. We can talk about that now if you want. I was just trying to see if what did the biologists say about the regrowth? Okay, so from the biologist point of view, here's the problem. Right, they didn't see this mass bleaching all last century, right? So you can say, I think the answer is, they weren't looking for it. They didn't really notice when huge amounts of coral died. Maybe that's plausible. Maybe they just didn't notice it. Maybe we didn't have boats last century. But anyway, they never saw mass bleaching on the scale in the last century. And they started predicting it in advance as they saw temperatures kick up from what they could know. You can find the paper trail in the literature. And then suddenly it started kicking off, 1998, you get one. And then 2016, you get.
So, I need to stop you here. I need to talk. I need to do
something. Sorry. Go ahead. Yeah. I want to get to the regrowth problem. If you just want to hear what.
So what I see, this is all hand waving. It's not actual data. So I'm looking at data from the Great Barrier Reef. I'm going to put this up on Twitter, et cetera. The amount of cover from 1985 to recently. And recently it hit a high. It's higher than every other year. How do you explain that? If CO2 is so terrible for coral, why? What happened?
Sorry, I was trying to get there. So what they see is these spikes in mass death.
Okay.
Expecting in between those bouts of death that you would have regrowth of some kind. So think of it like, burn down a big part of the Great Barrier Reef, of the Amazon forest, and you come, and your measurement is, do I have living things on the ground? Okay, so I burn a big chunk of the forest. I come back in a couple of years and there's weeds everywhere, and I say cover is great. The Amazon forest is actually benefiting from the burning down we did of the existing, sort of tropical rainforest. But you can measure the diversity is down. You can measure the types of species. So the fast growing coral that you're talking about is Acropora. This is well known as essentially weedy coral species. It doesn't, when biologists talk about reefs, they talk about the functionality of the reefs. Like, why are they valuable? Well, they're valuable because they are this cornerstone of many of the ocean wildlife species breed there, right? And they have certain characteristics of what they need for all of that to function. Certain kinds of coral build the reef structurally that provides resistance from storms and a lot of things. Anyway, acropora is not really the big functional, and it is spreading like mad. That is absolutely true. It's also sort of known amongst biologists as the first to grow and first to go. It's not very resilient. So we'll see how it fares. This El Nino will be a good test this winter. So all of us in the climate debate should be checking out what happens. And it varies a lot according to how the currents go and how much of that hot water gets to sit on there. But the expectation is over time, hotter water, more of these events that kill things off. And through the subsequent bouts, there is a measurable decline in the biodiversity and the types of species in the coral. So that's what they talk about when they talk about richness.
So how did coral get through the warm periods in the past? Didn't it thrive throughout those warm periods? And that's why we still have a Great Barrier Reef? It was much warmer 4,000 years ago?
As I just said, when it was warmer, the coral actually moved away from the equator. So, but this is something that happens over thousands and thousands of years, right? And then it moves back. Like the Great Barrier Reef, where it currently was, the water, it wouldn't have been there during the last previous to this warming period because the sea level was much lower, right? So the Great Barrier Reef wasn't even there. So obviously they do move around according to where temperature is, but remember, when you go look at those geologic timeframes, you're talking about tens of thousands of years. And when we're making decisions here about humans, we're talking about decades and hundreds of years. So like if the Great Barrier Reef, declines, you're looking at that for our kids' time time on Earth, et cetera. Now, maybe if climate stabilizes again, hundreds of years from now, you get new reefs and new locations that approach the richness of the Great Barrier Reef that we inherited. But that, that's a lot of impact in the near term. And do all the ocean species that are impacted by that loss recover, given all the other stresses we're putting on things? I think that's the perspective.
So do you think the Great Barrier Reef, there's something about it right now that's worse than it was in 1985 that's affecting it?
Measurably. It is. The richness of the species is measurably decreased. You have, the proliferating species you're highlighting in the cover chart is significantly acropora. You can look that up. And that's what Great Barrier Reef Marine Park Authority, Australian Institute of Marine Sciences, this is the thing they're all talking about.
So you're thinking there's a causal chain from the CO2 emissions all the way through, there's less of some species out there between 1985.
Yeah,
absolutely.
Death is the connection. It's a very concrete impact. And it's, the connection between the heat and the death is actually very solid. So you've got, you've got satellite monitoring products that look at the degree heating weeks, which is just sort of the cumulative heat stress above the norm that coral is. Competitively, coral really tries to get close to its heat tolerance because it's a little more efficient it's essentially converting oxygen or converting energy. And so from the sun and so you raise it on it a bit. They've clustered near the top of their tolerance, and that's why you see this dive. And so it's a very tight map between elevated temperature and the bleaching severity. If you've seen those charts, they're almost exact, right?
All right. So if the oceans were to warm somewhat, would we get new coral coming back to places where it used to grow, but it's been too cold until now?
Yeah, over time. And then the question, but you need a number of things. You also need stable sea levels because and so if the seas keep rising, it's hard for a reef to figure out. So you need climate to stabilize overall probably because they need conditions. Yeah.
Do you think more of our oceans right now are too cold for coral rather than too warm for coral? If the oceans were to warm, let's say 2 degrees, would we have more total coral or less globally?
Yeah, and you're talking about in thousands of years, not in human time frame.
Maybe even in human time frame. I don't know.
Yeah, in human time frame, I don't think there's any. But I'm not an expert on trying to map that out and see where the locations are where I take hold. But I don't, from everything I've read, they're not. They don't see a lot of spots where like, oh, we're going to have a fantastic year really soon.
Okay. All right, let's generalize now just from coral to life in general on Earth. Why should we believe that the Earth is too hot for life on Earth, and maybe cooling would be good for life on Earth. That's kind of the narrative that it has warmed since 1850. I'm not saying that humans caused it, because I don't think they caused all of it. We don't know. But has that warmth been good for life on Earth? I say clearly that warming has been good. Do you think it's been bad and we should go back to that temperature?
Which warming? The warming in the last
Since 1850.
Since 1850.
Yeah. Clearly good for life.
I think that I think it's perfectly possible some amount of warming has, and I think even the warming, even the very strong greenhouse warming overall, is inevitably going to have some positive effects. The question is, sort of tallying the positive against the negative. And so I think always interested in evidence and data on what the positive is. But I think, like you said, you talked about hand waving. Like what are we specifically talking about? It's a lot of different topics, right? It's impact to species, it's impact to economies, and doing a full cost benefit. You also roll in the kind of this very difficult to understand roadmaps of innovation. Should we have been innovating in alternate energy technology earlier? That's our belief. But I think a fossil fuel supporter says no, because this was cheap and it was worth whatever destruction we do with it. It's worth it because it's been cheap energy, right? So, these are big topics. I think if we could just stop warming where we have gone to date, we'd be delighted, right? But it's not how it's going. It's still spiking straight up because we're still emitting a ton.
But there's this narrative that experts have looked at all this stuff and they've carefully balanced the positives and the negatives. And experts have told us that it's been a negative, that the warmth has been a negative. But have they done that? Because I think they haven't. I absolutely don't trust that anyone's done that and found out that the warming has been negative, when warming is very much good for life on Earth. Longer growing seasons, good for our crops.
I guess I don't know who has claimed that specifically, that to date, it's dramatically clear that warming has been net negative. There's certainly plenty of negative. We just talked about some of them. I usually see in the IPCC language, a sense of the challenge is the warming we're baking in under the trajectory we're on, the difficulty rolling this back. Once the ice melt gets rolling, you can't get that water back up on the land. It just keeps coming and coming. And we've got a lot of cities sitting right at sea level. And once you get to a point where that water during a storm surge, that water starts pouring into all your subways and stuff, the cost spikes, right? So
let's talk about sea level. What do you think about the whole issue of sea level? Recently, I think NOAA and NASA was saying we had maybe 8 inches of sea level rise since 1870. That's after about 400 feet of sea level rise over the last 200 centuries. So I don't know how much of that 8 inches was caused by humans, but how big of a deal is that? How panicked should we be about 8 inches of maybe possibly natural sea level rise?
I would say the predominant evidence is that we've entirely caused the modern warming.
Okay, what is that evidence?
And I would say
I need to know what's that evidence?
It's building from the physics-based understanding of radiative balance, right? So we saw and you can come at it from a sort of kind of default. We saw the climate slowly cooling according to all our best, global multi-proxy reconstructions. We see the Earth was just very slowly cooling, at least 6,000 years or something, with some ups and downs. But, overall, slow cooling over 6,000 years. That's consistent with the current pointing of orbital tilt, right? So the Milankovitch cycles that set the ice age timing are currently pointing in a cooling direction. We see slow cooling. So, if you go back and try to reconstruct, okay, what's influencing the energy balance, meaning the solar balance versus what we know about the outgoing infrared balance. We see, the best estimates of reconstructing that show that this rough, slow cooling would have continued, past the little ice age, and just kind of continued. Instead, we put a lot of greenhouse gases in the atmosphere.
Well, so you think if humans didn't exist, hold on, you think if humans did not exist, then the Earth would be cooler right now than it was during the depths of the little ice age?
That is, like I said, there's obviously a counterfactual. We don't know because we can't run that experiment. But I would say that's the predominant evidence. I wouldn't say that's like ironclad. We know exactly what the temp would be without our influences. That we don't. But that's, sort of from the evidence that we have, and we generally think that things capable of cooling and heating an entire planet ought to be kind of visible. And that's that could be a wrong assumption.
Could be. It is wrong.
Well, okay. There are things we can't detect that are doing things. Okay.
No, I'm saying no one understands the Earth's climate. Nobody does. It warms and it cools, and it's incredibly complicated. And to just try to say it's basic physics, et cetera, no, it is not.
Well, it's complex, but
it's very complex.
This I would say, from my side of the skeptic fence point of view, this sounds like the sort of mistake of saying any uncertainty means totally uncertainty. We live on this planet. We have extreme, we commonly talk about planets light years away, what we're learning things about. The idea that we can't learn something fairly big, like how is this whole thing warming on our own planet, I think is quite a stretch.
Well, what's the explanation now? So let's talk about just the ups and downs just since the year 1900. It warmed up to maybe the 1940s, then it cooled through maybe the mid 70s, then it warmed again.
Not really cool.
You don't think it cooled since the 1940s?
No, I don't know. I mean, let's pull up temp. Let me see. I guess since 1900. Yeah, I mean, really just, there. Yeah, you're right. It's a little bit of a dip from like 40 to 50. Yeah.
What caused those recent ups and downs of temperature?
Yeah.
I've seen all sorts of hand waving about it, but what do you think caused it?
Oh, well, what do I think?
Yeah.
What I can pull up what, sort of NASA thinks. And let's see so you get, I think, particularly some of the stuff around like early 20th century, you still get a lot of interesting research trying to puzzle out what happened exactly with all the different pieces.
Okay, that's very important. So we don't understand natural variability. That's extremely important.
No, I mean, that's fair, but we understand. Make a distinction between it's hard to puzzle out exactly what happened in the past when you don't have all the measurements that you want versus can we, sort of observe things now, right? So, and, we do know this was the same Earth. So we don't really expect that there were mystical different forces we didn't know about back then, right? So within the physics framework, we can look at it and say, hey, from what we know of physics, what is visible, what we understand from the physical laws we do understand, this is explainable. And then you can say, okay, well, that doesn't mean you totally understand it all. Fine, science doesn't claim to understand it all. But, can you make rational decisions from what you can see in the physical laws that you know? That's kind of the debate, right?
Let me point out something here.
Eric, I would say, contrarians use this against scientists, right? To say, you also were concerned about cooling influences of humans. Well, that was true, right? The pollution that you put into the air does a slight shading of the air. And that is still true. That's still the number 2 influence on the climate is ourselves, right? Our number 1 is our greenhouse gases, methane, carbon dioxide, et cetera. But we still shade the air a bit, measurably, and that affects how much sunlight get it and executes a cooling. And so you see some interplays of these things. You see El Nino giving you the stair step and the temperature. There's a bunch of factors that are known, and there's a bunch that are just really hard to measure and know exactly.
Yeah, so I am hearing it's gotten so farcical that you hear people blaming coal plants for the warming. After 1975, coal plants released more CO2, and that was a big part of the warming. And I've heard also just as an ad hoc explanation of what caused the cooling before that, also coal plants, because the aerosols emitted by coal plants caused the cooling. I've even heard some of that. I think I've heard that for the hiatus that occurred after that, maybe starting in 1996 or something. Also,
and then what happened after the hiatus? So yeah.
That warmed again.
I think we should use the hiatus as a learning opportunity because, it was this big debate. The entire contrarian world was just wrapped around this thing as this huge deal. And scientists were saying, okay, yeah, but the underlying fundamental physics means that this thing's going to keep going, and it did. And
it did, but maybe it's going to cool next, though. Maybe we don't know.
Okay, I've been in this debate 30 years. I've been hearing the cooling around the corner every year. So yeah.
Did anybody predict the hiatus on your side? Because I'm constantly hearing, "Oh, look, our models are so great," and nobody predicted the hiatus. It was a surprise. And just before we leave it here, I have something else to share with you. I have something else to share with you before we leave this. We're talking about trying to explain what caused the cooling after 1945 or so. I'm looking at a ClimateGate email from the cooling after 1945 or so. Phil Jones in ClimateGate 2009 on altering mid-20th century sea surface temperatures to be, quote, better for the sulfate aerosol argument. It was always quite difficult to explain the rapid cooling 1945-46 from the sulfate aerosol argument. So there they had this, that was their explanation. And then they were thinking maybe we should just change the data and then we won't have to have this explanation. Oh. Yeah, that's pretty embarrassing.
This is I don't know. You have to, in general, the quote mining from these things tends to be taken out of context a bit. And
wait a minute. Well, what's the context here? That's not out of context.
I don't know that particular quote. And if Phil is, individual people can do and say the wrong things. That's not like evidence about the real world, right? So
it's Phil Jones. I think you're just saying out of context because you don't like the quote. I think that's what they've done. They've had ad hoc explanations, and maybe we'll believe it. Yeah,
there's a ton of attention and studies on the adjustments to the temp record over the 20th century. I don't think there's any evidence whatsoever of, despite the endless claims of conspiracy and fraud and NASA doing whatnot. This has been independent teams have been put together to reproduce it themselves from all the raw data, and started skeptical and came up just reinforcing what we know about the data record. So, we can get into that. I think that ultimately, because the evidence that we know supports the story that you see in textbooks and so on, it's natural to get into, to lean into this conspiracy adjacent state and say, have they been lying to us, and find this quote that proves to us they've all been lying, but they haven't all been lying, right? This has all been independently verified. All, the net adjustments actually reduced measured warming over the 20th century.
Who has independently verified it? Like, you're not talking about Steve McIntyre. Well, how about Steve McIntyre? He did some independent checking. I think you tweeted about him.
He found some helpful things. Yeah.
He did what now?
He found some helpful things here and there, but he didn't debunk the temperature record fundamentally. He claimed to debunk the.
Well, no. How about the hockey stick? I think you've tweeted about the hockey stick, and you're a fan of the hockey stick,
right? That's the paleoclimate debate. Yeah, we have the data that we have. The largest global reconstruction would be, I think, Pages 2K and then now Oceans 2K. These sort of reinforce this picture. I think you can throw out everything Michael Mann's done. That's the nature of science, right? You can throw out Michael Mann and everything he's done, and it doesn't change the picture that we have based on the totality of evidence we have.
Are you okay with throwing out the paleo data and the hockey stick then?
Well, I'm saying Michael Mann's paper. I wouldn't say, I'm not a big fan of throwing out data. No, I think we should use the data.
Okay. All right. So here's another ClimateGate quote I'd like to read from you. 2005.
ClimateGate was 15 years ago, Tom. But okay, go ahead. It's here. I think what we proved is that in terms of moving the political debate, trying to fight the science is hard, but ClimateGate, trying to quote things and show that scientists are evil and have plots against us, that's been very effective. So I don't blame still trotting it out 15 years later, but let's hear it. What
2005, Tom Wigley on paleo reconstructions. The differences between them prior to 1850 make me very nervous. If I were on the greenhouse denier side, I would be inclined to focus on the wide range of paleo results and the differences between them as an argument for dismissing them all.
Yeah.
That's pretty serious stuff from the inside. Are not admitting that on the outside, but on the inside, when they're talking to each other.
They're also not saying they agree with that. They're saying, this is what we're going to hear. Do we have answers for it? I think it's a healthy thing for them to be asking themselves. It's what you should be wanting them to ask themselves.
Wait a minute. As an insider, he is very nervous about paleo reconstructions. Why should I trust them? If the insider does not trust them, which he didn't.
He didn't say that. See, that's where
very nervous.
You're interpreting. Okay. So, any of us can look at, like, I mean, look at the pages by the different bins. There is variation across these, and there's a lot of uncertainty. So you don't get a precise picture with proxy data. What you do is, I think what's lost in our surface level sort of discussion of these things, and neither of us are experts, right? How much depth there are to these conversations. So, they look at these things for markers to line up, right? There's geologic events. And so if your proxy reconstruction, tree rings or something else, doesn't align with some of those things, and there's studies that kind of understand why. And over time, they build a better sense of what the sort of, they can do with different kinds of proxies. And so it's not a simple story. But, we can't, like, we'll commonly talk about, you've already brought up things that happened in the past that you take for granted. All of that is known for proxies, Tom. And so you're commonly saying, like, hey, when it was much warmer, blah, 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 blah. Why do you believe that? But then turn around and say, oh, but I don't trust any of that, right? I mean, you see that.
Well, is it all known from proxies? Or how about the tree line? Like the northern tree line in the Arctic from 4,000 years ago, we have tree stumps way north of the current tree line. That's not a proxy. That's just an observation. What are those tree stumps doing up there? If it's so hot right now, if it's way hotter than it was 4,000 years ago, why are those stumps way north of where the trees are now?
No, you'd have to. I have no idea that specific one. We'd have to look. But
okay.
These are.
Yep. And then Tony Heller in general. I don't know if you're a fan of Tony Heller, but he goes back and looks at
I'm a skeptic. Did I say I'm a skeptic? Go ahead.
Well, no, the way we know, for example, that a lot of weather was really bad a long time ago is he goes back and he looks at actual weather reports, which cannot be fudged. If you go back and look at what it actually says, you can't adjust that. I think a lot of people on your side don't like Tony Heller because he goes and finds all this stuff showing that fires were really bad in the old days and the cyclones, et cetera.
I don't. Go ahead.
Well, no, I'm just saying that these actual observations, historical records are incredibly important.
Well, let me start by a point of agreement, which saying that, I think we can be frustrated all around, both of us, by how media treat some things, right? And, for me, that includes, trotting out Peter Ritt as the authority in all things. But on the other side, it also includes media needs to sell. And so if they can spin a climate narrative on the latest storm, they're always going to do it, regardless of, how strong of a link there is. Weather and climate are different problems. And massive storms and things have happened through history. And I think it's absolutely fair that sometimes those things are overhyped. Now, I step back and say, what is the bigger problem? Have we under-responded to greenhouse gases or have we over-responded? And if I thought we had over-responded, I would probably spend more time sort of critiquing the things that drive that. But in reality, we've wildly under-responded. And so that, tends to be where I have more concern. But I would say, Tony specifically, I've looked deep into his work. It's not accurate. He misrepresents data adjustments in the United States.
Specifically, what has he done? Any specifics about that?
He posts charts of what happened in U.S. temperatures that are just inaccurate. People have dug into the techniques he's used to construct them, and they're just faulty. For example, he tends to pretend that, that in the so globally. And you'll never see him mention this. His followers genuinely believe that he's shown that NASA has, fudged the record, right? And that there's, he's a big conspiracy guy, right? In reality, the global record, the net adjustments, homogeneous, we can all talk about why there are adjustments. There absolutely are necessary adjustments. Globally, they actually reduce the amount of measured warming. So if that's contrary to scientists, maybe you could say they're a really good conspiracy, and to throw us off, they actually made it look like less warming, but you're really getting deep into the conspiracy. In the United States, that's different. In the United States, there actually was adjustments that increased the warming, and that's because of the time of day bias, right? So they moved measurements from the middle, like noon to dawn over time. And Tony wants to say, that means it cooled, right? The numbers got smaller when we measured at noon and we started measuring in the morning. And so we should recognize that as cooling. And when you adjust the data, it's fraudulent. But that's just really poor logic. He does that routinely. As far as what he says about weather report, yes, he goes and finds fun weather reports from the past. And sometimes I think that's valid to point out, like media's overhyping some storm or something.
So you don't think that there's been adjustments to cool the past? I'm constantly seeing adjustments where time after time, as we get more and more, as we get new data sets, for some reason, data from decades ago is being cooled. You think none of that's going on? You think the data from the past is being warmed?
Let's step back and look at the big picture. The net story is that the globe, the past was warmed, okay, because of the ocean data. The major adjustments to the ocean data in the history that was warmed, that offsets any of these smaller. And okay, remember the nature of these sort of ecosystems of media and discussion, right? You're saying I keep seeing the ones that that cool the past. Well, of course you are, because those are ones that are going to go viral in all of these contrarian communities. That's the one everybody's going to repost. Nobody's going to repost a study that says it warmed the past a little bit, because there's no reason to share that within those. That's not what those ecosystems are hunting for, right? So you can make sure you go look at what actually happened, and and if the net story is that they net warmed the past, how can this conspiracy hold, right? How can this plot to constantly?
So who net warmed the past? And do they keep making adjustments to warm the past so that the total warming is less?
Yes,
and less?
there are little adjustments. There are little adjustments, from time to time.
And they're consistently to warm the past.
No, not consistently. The little ones are all over the place. You can go, people have done studies. What have these been? And, the data set that is more adjusted than the surface is Roy Spencer's UAH, but you don't hear contrarians complaining about the number of adjustments in that one. The warming of the past, I think, has happened in all of the major sea surface temperature data sets. And I don't know who totally owns all of those and the history of those. We're probably getting to the edge of my expertise on exactly where all those came from, but an interesting sort of research topic of how they came to that. You look at I went very deep on the NOAA controversy, which is similar, maybe one of the ones you're pointing to, where it was near the end of the hiatus, and it looked very suspicious that they were cooling the past in that case. That happened to make in their record the hiatus statistically go away. This clearly was a plot on NOAA's part. But, if you go back 8 years prior, they had said they'll need this adjustment. If you look at the reasons for the adjustment, it was very obvious that they were putting more buoys in, et cetera. These things completely collapse when you look at them.
So you still do believe in the hockey stick. Am I correct there?
I believe the data we have shows this long, the picture that we have, the long, slow cooling near the end of the Holocene, and upticks at the end. And, we know a lot more about this last 100 years because we have it covered, in different kinds of sensors and satellites and thermometers. And so we're quite confident of the warming in the last 100 years, which is very significant compared to what we see in the historical past.
So from my perspective, the hockey stick very much cooled the past, where it made the medieval warm period go away, which was very important in selling this whole thing. Do you agree that cooled the past?
No, because, the previous, I think what we saw with global multi-proxy reconstruction was pretty consistent, and the medieval warm period is much more pronounced, looking at regional data. So I think it was primarily the shift from regional to global that you see a flatter shape to that decline through the medieval warming period. As far as I know, I don't know of any sort of global reconstructions that show otherwise.
Okay. What do you think caused any medieval warm period? What caused the warmth leading into it and the cooling leading out of it?
Right. And I think some of the right, and it's right to highlight that uncertainty goes up as you look at this intersections between weather and climate. Okay. So weather is conceptually, weather is the fluid swirling of Earth's surface, the air and the water. It's fluid dynamics. It's very unpredictable. Not totally unpredictable, because there are there's jet streams and things that, you can sort of model from, and that's where we make progress. But climate is about, in this context, is about the energy budget, like the differences in energy over time, right? And that's why one's predictable and one is not. On the border, it gets real interesting. And so what happened with major currents? What is going to happen with sort of major currents, and how weather patterns form in a region. Is it going to have more drought? Is it going to have more water? Those are much harder problems. El Nino itself is essentially more of a weather phenomenon that happens over the course of many years. And so you're right, those things are not well understood. And, so I'm sure there probably has been research on what formed these regional patterns, and I don't know what it is.
So from my perspective, this whole scare is about scaring us about modeled things that are going to happen in the future. But we have been emitting CO2 for hundreds of years. What do you think have been the very worst things that have happened as a result of that? Have cyclones gotten worse? Have crop yields gotten worse? Fires, droughts, floods? What has gotten worse because of that warming?
Yeah, I mean, I think that's... Well, we talked about one that, I personally have gotten passionate about as I understood the extent of it with the things like coral dying on that scale.
Okay, so global cooling would be good for coral, according to you.
I think so let's go back to what I said at the beginning. Ecosystems and human societies both adapt very intensely to a given climate range. So stable has value, and it had value in human history, like being able to have stable sea level and have oceanside settlements that develop over time and do trade and do fishing. That was valuable to civilization, right? And now we're saying we're going to be raising sea level at a rate that it's pretty hard to have a stable seaside, sort of settlement.
Do you think that humans have the ability to stabilize climate? And if we were facing natural global cooling, would you say that to stabilize the climate, we should try to warm the climate, maybe burn more fossil fuel in order to keep the climate stable?
If humans are causing the warming, then of course we have the ability to stop causing it and to slow things down, which would be more stable. I think it's not realistic for us to get to stable based on our trajectory, based on our economies, based on our levels of emissions. So the rest of it gets kind of really hypothetical because we are spiking into the sort of we're headed towards Cretaceous hothouse, baby, as fast as we can go in a stunning geological turn. And so the idea that maybe we should worry about cooling, I mean it's irrelevant. It's similar to the argument that maybe we need more CO2 because we're getting to the lower threshold of CO2. Well, not a problem. We're spiking upward. To answer your question,
okay.
I was saying your cooling question. I would say, you'd have to get more specific about the scenario. Why is the cooling happening? How long is it expected to happen for? If it was like we got hit by an asteroid and we got 100-year nuclear winter. Shoot, maybe we should emit greenhouse gases to try to save ourselves. I don't know.
Okay. So how sure are you that CO2 is the climate control knob and that if we just keep emitting CO2, the Earth is going to just keep getting warmer? What's your level of certainty and where are you getting that? Because I don't believe it.
Sure. This is an important point. You hear people say it is. So in actual scientific theory, I think all scientists would agree it is a control knob. They don't claim it is the. Right now, it is the knob that has been cranked and is causing warming. Historically, it's a pretty significant one, but obviously solar output is as well. And I would say scientists would say the other big ones are like ice cover, the level of reflectivity, or key to, you can't reproduce the ice age cycles if you don't have solar, ice albedo, greenhouse. You need those three big ones, at least for our last few million years. And in fact, with only those and a little bit of, sort of modeling of regolith removal, how fast did the glaciers move, you can reproduce the ice ages pretty well. That's one paper that's been done, which is a sign that we're in the neighborhood of this. These are the big factors, right?
Oh, you do think that CO2 is the reason for ice ages coming and going?
No, one of the...
I do not believe that.
I just said one of the three big factors.
Okay.
Along with, solar insolation and orbital in this case, ice albedo.
Okay.
So,
where does CO2 rank, though, among those three?
Well, interesting question. I don't know that I've seen something that tries to rank those over the 3 million years. Okay, so right now, you do see rankings. The IPCC publishes the radiative forcing estimates that they have for these different things. And CO2 absolutely is number one right now.
So they're saying, I think that's
quantitatively number one, right? You can measure joules, right?
Yeah, they think CO2 is maybe 10 times as important as solar influences. I think I've seen that.
Right
you
now.
That? What do you mean right now?
In the last 100 years or so, the sun's been very stable. The amount of radiation reaches for the sun is quite stable. The sun generates all the heat we feel around us. But for it to heat the planet higher, it has to get hotter itself. It hasn't. And it's, it's.
You think that the only solar effect on our climate, the only thing that can happen solar-wise to change our climate is the sun can get stronger?
In known physics, in known established physics, it is the energy. It is the joules that get here. There are great theories. I think it's fantastic to have the cosmic great clouds theories and all these. They haven't held up to testing, which is important in science, right? They've failed key tests.
Which tests have they failed?
Well, they like both at people trying to independently reproduce the claimed correlations, right? So you see a lot in the, Willie Soon type work. You see a lot of correlation argument. We mess with this data set and we mess with this data set and we found some alignment. So we think there must be a cause, but there's no physics there, right? And it's the same. Do
you think CO2 has that claimed correlation? I'm seeing tons of graphs at all time scales that do not have that correlation.
CO2 has the core physics. The correlation, you have to look at all the factors, right? So as I said, there are multiple factors and reduction fallacy, I use the term a lot. There are multiple causes. And so you can't claim to be testing one cause when there's multiple in place, right? And I don't think scientists actually do that, but contrarians say they do that. But I would say, what is the evidence for CO2 in current times? Well, it is, we have satellites that we have laws of physics that predict exactly what the radiative codes are, what the changes are going to be to radiation at the top of the atmosphere. We have satellites that sit up there and they watch it happen exactly as predicted. And so, that's where the confidence in greenhouse gases comes from, the core physics observing it. Conservation of energy. This is a powerful thing. You can't have less energy leaving and not have it tally somewhere in the system.
Why didn't this work during the hiatus, though? We emitted enormous amounts of CO2 and the Earth did not warm as predicted. Then afterwards, we got 66 excuses for it. We got enormous amounts of excuses. If the science is settled and it's basic physics, why did we get 66 excuses?
And then what happened? It kept warming despite all these protestations. Okay, all throughout that period, OHC, right? We've had Argo since 2000. All during that period, heat content in the ocean to 2,000 meters in depth was rising. So that's where the energy was going. Greenhouse effect is still happening. Now, you have to lay in. And so, as simple as charting your El Niños and your La Niña points over time, you see a consistent rise even through the hiatus. So the hiatus happened to be a time when ocean currents were churning more, right? So the water, the warmth that's being absorbed in the surface is just getting mixed better. And then suddenly you get an El Niño and that heat gets to come to the surface. Doesn't come from nowhere. It's not like, magic that the El Niño created. That heat was there and it comes out and now it heats the whole planet, actually cools off Earth slightly during an El Niño. And that's happening right now.
From my perspective, things like ocean currents and sulfates and all sorts of things, they seem to be pulled out just when they're necessary to explain why something didn't happen. And then they go away. Nobody talks about them. Like when it warmed, maybe the ocean currents switch the other way and it caused some of the warming.
I can understand how it could feel, though. I think that if you look at the published research, you'll see that research is ongoing on these things. There's a difference between the scientific world and what's being researched and what's being discussed, and then what pops out to our level to sort of goes viral and that we talk about, and you have to be mindful of that difference, I think.
Yeah, from my perspective, there was this great Pacific climate shift in the late 70s that ocean currents changed. Something flipped a switch up in Alaska. Very quickly, Alaska temperatures changed. Something flipped. It wasn't CO2. I don't think it was anything we could have done. I think the climate is incredibly complex. Something switched, and if it switches one way, it can switch the other way. And I think more surprises are coming. I think cooling may be coming. I'll be surprised if we don't see cooling periods between now and 2100.
Well,
we're constantly surprised. Yeah.
Many contrarians have made bets about that and have lost money. So I would advise you not to bet against one.
No, I don't understand Earth climate. I don't know which way it's going. Are you confident enough to bet that there won't be any cooling periods between now and 2100 if we continue emitting CO2? Are you that confident? I think you're not.
Any cooling periods? No, because, you
30 years. Yeah.
You get the right volcanic eruption, you'll get cooling for a couple of years, but then the sulfates will fall out and the warming will resume. So again, from a physics perspective, what you're talking about with Alaska and stuff, shifts in ocean currents, or where the warmth is going, absolutely can have those big effects regionally. But then if, why you don't see those in global metrics is because the heat's moving around. It doesn't come from nowhere, right? And so that's the same thing, that's the argument about it's ocean patterns. It's it's AMO, whatever. Those are about heat in the ocean sloshing around, and heat sloshing around in different ways cannot heat the ocean itself to 2,000 meters. You need a change in energy budget at a planet level to be warming the oceans globally like we're seeing. So it's not this natural variation changing in currents. And that can cause some wobbles just like El Nino does. And that's and that's harder to predict because it's more adjacent to weather. But the underlying physics is driving it up is the point.
Why do you think it was so hot, at least in the U.S. in the 1930s? Like just looking at the local data where I'm from, we hit 100 degrees 38 times in 2 decades. Since 1988, it's been less than 10 times. It was tremendously hot back then. My dad's old enough to remember it. He remembers how hot it was. Yeah. Why was it so hot then? And why, in all the years since, why hasn't it gotten that hot again? All those years. Yeah. Nothing like that. Why?
Well, I think we finally beat that, or at least at a country level average. But regionally, there are probably still high points from that period. I don't think Dust Bowl. I can't say recently I read any sort of assessments of why that heat wave happened. And as I've already agreed earlier, there's definitely heat waves happen, storms happen, tornadoes happen. There's definitely a tendency of people to over attribute climate to, every bad thing. I'm 100% happy to agree on that. We see too much of that.
Yeah. So maybe I already forgot what you said when I was asking about what are the worst things that have happened because of the warming. You mentioned
I think
how about the storms and floods, droughts? Are they getting worse? Because I think they're not. Objectively, I think they are not getting worse.
I think those are challenging areas. I'd say, where does the evidence come from that they have? So one is, there are some physical factors. So for example, you simply have higher sea level rise. When you have storm surge, your water level is now at a higher level. And so there was a lot more flooding, for example, in Hurricane Sandy in New York with that extra 10 inches of water that they have than there would have been if that extra 10 inches of water wasn't there. So that's a very concrete element of things that have.
And you're blaming all of that 10 inches on humans. You think humans caused.
Yeah. Well, we do think, again, based on the physical evidence that we have, humans have dominated the warming, and it is the warming that we think has caused sea level to kick back up. It had gotten quite little levels of sea level rise prior to modern warming. So
that last 400 feet of sea level rise, that was all natural, but then the last 8 to 10 inches was all us. That's what you're saying.
Well, I might be talking out of turn about the attribution of the sea level rise, et cetera. I think it's fair to say, if we think we did most of the warming, we also did most of the sea level rise, just because when the Earth's cooling for 6,000 years, you really don't expect sea level to take off, right?
What percent of the warming since 1975 do you think humans have caused, and how would anybody know?
Look at the forcing chart. So if you accept this physics-based framework, then the energy budget is set by joules, right? Energy. Watts per square meter as a proxy kind of for this. And there could be areas where that theory is wrong on the edges. But if you look at that, if you go quantify the best we can, then you just look at the forcing chart and you see that CO2, then it's like methane. I don't know, the aerosol cooling, it's got the bigger error bars because it's harder to measure. That factor is still there as well. Now, the flip side of that is as we clean up, as India and China clean up some of their particulate emissions, that actually that's gonna hurt us on warming. It's good for the air. I mean, if you've been to Beijing, I've been to Beijing. It's like the days can be ugly brown skies. That'll be good for them, but that brown sky was actually a little bit cooler. So we'll see that, and that's where it comes from. Our best estimates of what we can see influencing the energy budget.
So we have these best estimates, but I see all sorts of estimates still to this day about how much warming we should expect if CO2 doubles. I see some people saying 0, and I see 0.2, and I see 1 degree Celsius. I see maybe up to 6 or something at the high end. All sorts of published studies, numbers all over the place. If this is basic physics, why are the numbers all over the place? Why don't we just have one number?
Yeah, the core warming, is understood from basic physics, but you pretty quickly get into the uncertainty of the ECS range. Particularly, I think you probably know, cloud response is particularly tricky to nail down. So there's we probably don't have time, but this is interesting. There's endless studies trying to estimate this sensitivity, both looking at paleoclimate, trying to estimate what were the forces that caused climate to move, looking at basic sort of current observational assessments looking at, and modeling comes into this a bunch, and you can sort of not trust the modeling, but, teams have built all these models that do have a bunch of skill, and sort of when you look at those, that's another source of what seems like plausible ranges for total warming. And so there's definitely things that, while there's a core physics that keeps this warming happening, there's tons of uncertainty around, particularly the cloud response and so on.
How confident are you that we understand even the carbon cycle itself, that we even know that the rise in CO2 since 1850 has been caused all by us? Because I'm hearing lots of folks say that we don't understand. I don't think we do understand the carbon cycle. Some of the CO2 that we emit ends up going to the bottom of the ocean via calcium carbonate. Will Happer says that in a growing cornfield, CO2 can go from 400 ppm to 200 ppm in a single morning. How long do you think the CO2 stays up there? I hear estimates between maybe 5 years to a millennia. There's all sorts of unknowns. Even in this one little area, there's tons of unknowns. What do you think about that?
And I think that's part of the argument. Is it's just unknowns everywhere. But the idea that they all break in one direction is incredibly, improbable.
They don't have to.
For carbon cycle, of course, it's complex, but I think you go back to for our purposes, it's easy to go to the common sense arguments. Look at what CO2 has done geologically. What is the spike on the end? It happens to be the amount of CO2 that is increasing the atmosphere is less than the amount we can estimate from our having burned, the economic factor that is oil. So if it's not us, where did this mystery spike in CO2 happen, and where did all our CO2 go? I don't think you can answer those questions. It's pretty obvious that we have spiked CO2, but of course you can get into a whole bunch of other analysis, isotopes, et cetera. Carbon cycle, incredibly complicated for sure.
So even throwing temperature out the window, do you think that life on Earth would do better at 280 parts per million versus 420 parts per million CO2? Because I think that the CO2 is very important in the whole chain of life on the Earth. CO2 is beneficial for life on Earth.
A stable planet at 420, which we're blowing past. I think would probably be very fine. The problem is we're blowing past that, so we're not even talking about 420. We're going to keep going higher. What we're talking about is very, very rapid change, and it's the change that is disruptive on human timeframes. You could say, step back, Earth's going to be fine, and in a million years, who cares? But I think we're humans, and that's why we care.
How is it disruptive? Are you not saying it's not going to cause more floods, more drought?
No.
Or is it?
I was saying that sea level rise, of course, you get more floods.
Because of sea level rise. Okay.
Well, that's one, of course, because of another physical thing is relative humidity. So you get more moisture in the air. So when you do have storms, you expect bigger. There's more water available in the air to dump down at a given time. Warmer air in a dry area dries it out, and there's a lot of evidence that shows that, because it's just physics. It's relativity. When you have hotter air, it gets drier. The forests burn faster. Any of us who have done a campfire know that hotter, drier wood burns faster, and in a fire, that can go from a small containable fire to a much bigger one, and those are one of the many factors that.
So does this warmer air with more water vapor in it, does that ever go over dry areas and produce much needed rain?
Deluge. Yeah.
Much needed rain.
Absolutely. Yeah.
It may be good for crops. It may prevent fires.
I think the problem is what they're seeing is that you more often get drought and then flood patterns, and that can be negative because you're not getting the balanced, sort of moisture. But I'm sure in some places it does have net benefit. I don't think, I'm not claiming that changing the world only strictly negative, but it is systematically negative because, we have sort of adapted to the stability that was previously there.
Is there any data anywhere that droughts and floods are becoming more frequent or worse?
Again,
I think they're supposed to be getting worse, but they're not. It's another one of these things. The theory says everything is going to be worse, but the reality, it's not. Yeah, I
think this is too. We're just both sides talking past each other. Scientists consistently say these are physical reasons, like the drying of wood. We all know that'll cause hotter fires. Over here, you're saying, okay, I'm counting the number of fires. What's going on? But this is not. This is looking at one factor. This is looking at many, 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 many factors, right? So that's the reduction fallacy point. You can't just look at I mean, there's arson rates, there's wildfire management, all these things have big roles in fire. But across it all, if you're making, you're taking regions that supported wet forests and you're making them hotter and drier. Over time, they just may not sustain those forests. They're going to keep burning because they're too dry, right? It's similar to the coral. The region no longer supports the kind of thing that lives there.
Isn't there way more forested area in the U.S. now than there was 100 years ago when CO2 was lower? We're supposed to think that increased.
That could be true. We went through a massive deforestation of the earth prior to that, and so maybe it's true. I don't know.
So, but is your prediction that under increased CO2 there would be less forested land on Earth? Everything else being equal? I don't think I know enough to say anything about total forestation, especially when you see like mass. I mean, China's been on a big tree planting campaign for years. I mean, humans have control of some of these things now. We're in control of the planet now, and depending on our policies, there are environmental policies that have, and it's funny because a lot of contrarians are anti-environmentalists, but then they'll turn around and say, look how good this forest is doing because of regulation that's protecting the forest, or look at how well polar bears are doing because of regulation that cut back on hunting bans. This is just one of many things we're saying, look, if we pollute less, if we emit less, it's going to slow the rate of this thing, and we're going to be able to manage these impacts a lot better. Are you worried that increased CO2 is going to be a causative factor in making polar bears go extinct?
Well, I mean, I don't know about they're certainly at risk of it. Habitat is always good for species. And so, I mean, objectively, they've lost tons of it. They're clearly better hunters on sea ice, and they're losing a bunch of it. And like local studies of where sea ice is depleted has shown stress on polar bear populations. I think it was a poor choice of a poster child because, it's something happening very slow, the retraction of sea ice. I mean, now we have, of course, cruise ships going through the fabled Northwest Passage, and we all pretend like, oh, that's no big deal.
That is no big deal.
Well,
because
we're changing the planet. Why we just like to?
Well, no, ships were going through there in the 40s.
Oh, yeah, not like now, not like a cruise ship going through. No,
I mean, even recently,
very hard to go through there. You can look at satellite imagery of the North Pole. You can't sort of claim that sea ice hasn't had a massive retraction.
It fluctuates. How about since the 70s when it was cold, sea ice was higher, but how about since the 40s? Or there was all these articles, newspaper articles in 1922 that we can't believe how warm it is in the Arctic, et cetera. That, it gets warm, it gets cold, back and forth. The whole idea that CO2 must be the reason that it gets warm.
The whole idea that the Earth just does things without physical reasons that you hear, the Earth just changes and we don't know. That's counter-scientific. We know quite a lot of this. We know that there must be causes for things.
Well, I agree there's causes, of course, that it changes. It doesn't have to even be external causes. It could be changes in how geologic heat flows from the Earth, as you said, ocean currents. All sorts
but is there evidence that is the reason? And it's been extensively studied.
There is evidence that all sorts of things are influences, but you can't tell me why any one of these changes have occurred in terms of temperature changes. You can't tell me what caused the cooling from 1940s to 1970s. You can't tell me that, right? Well, you can't tell me what caused the hiatus. You're guessing, I'm guessing, nobody really knows. But we're supposed to think that at least 100% of the warming since 1850 was caused by us. I'm hearing that.
And I can't tell you exactly why today is cloudy and not sunny here. But that doesn't mean that the physics of having more energy entering the system than leaving won't cause the whole system to warm, right? So you can have both those things. You can have uncertainty about some things, and you can have some knowledge. And so, I think you come to I think it's Bertrand Russell who said, I am willing to accept well-substantiated results of science for purposes of making rational decisions, while knowing that there's uncertainty, that there's detail, there may be.
Are you willing to accept that there's uncertainty, and if we double CO2 from here, we might get less than 1 degree of warming?
I think it's incredible. Well, if we double CO2, the CO2 on its own, so without water vapor feedback, is more than 1 degree. And water vapor feedback, again, is one of the most best known physical responses, which is the air gets warmer, you get more water vapor. Water vapor is a greenhouse gas, and so that amplifies it, typically another another degree or something. And so that's why the range is much more this, around the 3-degree ECS. And that's where you see most of the estimates land, and what's his name gets them down to, 2 degrees or something. But, I think it's very unlikely it'll be less than 1 degree. And that's not what we've seen, right? It's not consistent with what we've seen over the last 50 years.
We've already seen all sorts of temperature fluctuations, even since humans were here when CO2 allegedly didn't fluctuate. We're supposed to think, though, that CO2 is the climate control now, except we can see all these other fluctuations when CO2 didn't change. So a lot of other stuff must be happening.
Not at a global level, right? You don't see these fluctuations. That's the whole point. You don't see these fluctuations when you do like a multi-proxy global reconstruction. Okay. Remember, GMST is a metric, right? It's a measurement. You're adding up all the temperatures globally and averaging to get a number just to see what's happening with the overall energy budget. But that doesn't, that heat could be swirling around a lot, right? It's like with the, what's it called? The big change in ocean currents that happened coming out of the last big melt that came up. And you see, a sudden surge of cooling in the north. But at a global level, you don't see as big of an adjustment because, it seems like a major ocean current change. So, yeah.
So you're saying that over the last maybe 10,000 years, there have been no global cool periods and no global warm periods? They've all been regional?
No, of course. I mean, we can look at the data, right? And so it's got some ups and downs. And again, it's got a lot of variation between the types of proxies you use. You see some different things, but you see this general picture of a much flatter, slow cooling. So the Earth did not have, as a whole, you did not see spikes in energy budget where, holy cow, something's heating the whole planet. You don't see that in the record, I think, factually.
So there's all sorts of papers would indicate, as you look at the papers, that the medieval warm period was indeed global. But you are arguing that it was.
No, I don't think papers show that at all. I think what you see is, I think it's a popular thing to pick a bunch of things from around the world. It's a multi-100-year period, right? And so you pick a warm spot at a bunch of places and you say, look, this must have been global. But then if you actually do the global reconstruction, where you don't try to do that, you don't try to piece it together, you just take as much data as you can from all over the world and then try to see what that gives you. That's a global multi-proxy reconstruction. Those things have tended to go away. Yeah.
So medieval warm period, you think it was just heat moving around the world, but globally the temperature stayed the same?
I'm not an expert on medieval warm periods, so we could, okay. I could certainly follow up on exactly what they think. But I'm saying, if you look at reconstructions, you don't see these things as big events globally in terms of the Earth.
Okay. Getting back to the hockey stick one more time. What do you think of this whole idea that trees were thermometers and we can trust them as thermometers until 1960? Until 1960, then they stopped being thermometers. What do you think of that?
As far as I know, that's still something of a mystery, which is that so like I said, when they study proxies, they look for these markers in the past and see where they line up and can we rely on these? And for the most part, when they do that with tree rings, they look good until this modern period. And so I think there's a bunch of theories about how different kinds of we don't know all the ways we might be affecting tree life. And so our particulate pollution may have caused some changes or something else, but they seem to be, something has happened where they're, sort of, as I understand it, not growing at quite the same rate that they did historically. And I think it's right for you to flag and go, what the hell is that? I'm not a tree ring expert to tell you you're right. That is what the hell is that about? But on the flip side, from a climate gate perspective, it was known before. This was not something they invented. The tree ring dendrology experts had been telling them this before. And so, and it wasn't the purpose of that paper to study the current temperature, right? We have much more confidence in the current temperature from thermometers, like actual measurement. The purpose of that paper was to look back in the past, and the tree experts said, they do think this works like other proxies going back, but something's happened in the modern period. And so, yeah, I mean, I think it's a fair thing to raise and have doubt about tree ring studies from that. But there's a lot, again, there's a huge amount you could go read about that won't make it to our level of debate.
Yeah, but don't you think that whole tree ring fiasco is a pretty big black eye for climate science, an embarrassment for climate science, that this was trotted out? It was used in the IPCC. It's the gold standard. It's the Bible. We're supposed to believe it. And
it is held up. It is held up, right?
Wait,
so, I mean, more and larger global reconstruction have come and shown that shape to the past, which was the purpose of that study. I think you're focusing on the modern, on the stick at the end, right? And that stick was always, predominantly modern measurement, right? So like, do you actually, I mean, you don't think that the 20th century actually cooled and that the tree rings are right and the thermometers are wrong? Or do you think that?
I think the Earth has warmed, since 1850. The Earth has warmed.
So you agree that tree rings are wrong, but you're mad that they didn't claim they were right, which seems weird, right? Like they did. You don't think the tree rings were right about the 20th century. They didn't claim they were right.
The IPCC used this.
You say no. The IPCC had the put the modern measurement on the end, and that was the supposed scandal. Was that the two things were put on the same chart? I think that's the essence of the scandal, right? Is they showed the long, slow decline from proxies, and then they put the temperature reconstruction. Everybody said that's cheating. It's not really, but that was the scandal, right?
So how do we know that the shaft of the hockey stick was just flat? If it's not for Michael Mann's tree rings, do we have other ways to prove that it was flat and there weren't big fluctuations? We had instruments during the shaft, then we would have seen all sorts of wiggles. It wouldn't have been flat. That's what I say. Of course, it would have been.
Well, Pages 2K uses all kinds of coral and boreholes and sediments and ice cores, and that the hope is looking at all of those. That's why it's a sort of multi-proxy reconstruction, and looking at the different characteristics of all of them, and sort of looking across that, you get this general picture. And it's very complex, but it is not all dependent on tree rings. And so given that has been, essentially the test in science is not, look at this guy. Do you trust him? Look what he said. Do you trust him? That's good for the political debate. That is gold for you all. But in science, it's testing. It's independent testing. And so the fact that this, the largest reconstruction is done using all the climate data they could get, reproduces a pretty darn similar shape in science, that's the validation, right? That's that's what the National Academies points to.
Do you think it's ever scientifically defensible, though, to take proxy data that shows a smoothed proxy data and then just graft on instrument data on the end and then hand it out to the public? They handed it out to the Canadian public. That's how Stephen McIntyre got involved. He had seen so many hockey sticks, and clearly you shouldn't be doing that. That's not scientifically defensible, is it? I think it's not.
Well, I mean, you have to explain a reason why it's not. There's certainly theories why it could be misleading. I mean, these things generally were labeled as such, and so if you were feeling skeptical about how these different measurements work, you could dig into it. I don't think you've actually come up with anything, right? I mean, there's no evidence that that the proxy record is wrong. I don't think it's uncertain. There's lots of imprecision in it, but I don't think McIntyre or anyone else has said this shape looks fundamentally wrong.
Well, when Wigley said he was very nervous about paleo constructions, wasn't it him? Reconstructions?
Yeah, sure.
Nobody should be nervous?
Yeah.
I think, of course, we should be nervous. I don't trust them.
I think, I don't think it's the nature of scientists to just trust things, particularly when there's complexity and uncertainty. That's why there's so many studies on this. That's why there's so many sort of reconstructions. But as I said, we have the data that we have. They show, the differences that we're talking about really probably don't mean anything for the kinds of policy decisions we're making today, right? The big uncertainties about climate is what really is going to be the impact of what we're doing. Whether it was fractions of Celsius warmer 3,000 years ago, is just not going to affect a whole lot, right? Paleoclimate validates what seems to be happening from the physics-based point of view. The core confidence has always come from that physics understanding. This is how, Fourier inferred things in 1827, how Arrhenius was able to predict AGW in 1897. It wasn't computer models. It wasn't proxy reconstructions. It was physics. And so that continues to play out. And I think the big uncertainties are what's going to happen.
So speaking of uncertainties or what's going to happen. Do you think there's something magical that's going to happen if Earth crosses this 1.5 degree threshold from some undefined time in the past? And it starts to get dangerous then? Or maybe that number is 2?
I think the communication on this is, I think fair to criticize the whole, we have 1 year to act before blah, 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 and what they mean is we have to start acting now. So this curve bends later. So you see a lower curve, but how it gets interpreted is we got 1 year or we die. And then the 1 year passes, we don't die. And it's like, what the hell, you were lying to us. I think that has, backfired on policy people a lot trying to use that kind of argument. I think the 1.5, I think it's acknowledged in the IPCC that this isn't any magic number. There are tipping points where you have estimates or a particular threshold, but, they tend to be pretty broad estimates. The fact that corals dying at the rate it is now was not exactly known. I mean, it's possibly happening heavier and faster than they did predict it, but, we don't totally know where these thresholds are. So there are some tipping points. For example, with, Atlantic meridian overturning current isn't going to, we're seeing some signs of weakening. Is all that dumping of cold fresh water from Greenland gushing going to change fundamental patterns? Those are significant, and those would have major sort of economic costs in the regions that would change faster. But anyway, the 1.5 is not magic. I agree.
Well, what do you think about this whole issue of scaring children about this? Like young children, 7 years old, they can't sleep at night because they think something bad is going to happen. Or people holding up signs saying, you're going to die of old age. I'm going to die of climate change. And kids saying, I'm not going to study. I'm going to be dead anyway. I think there can be unhealthy aspects of that for sure. The world faces a lot of challenges, and we still live under the scare of nuclear accidents and bioweapons and all sorts of things that could keep us up at night. Climate, the good news is, we have been able to delay this long. The bad news is that the costs of that keep going up, and over time it is a worse world we're heading into than we needed to be heading into, and we're choosing that. But I think, it's also, children hysterical about the end of the world is not helping in anything. So do you think let's say a 1/4 degree of warming from here would make for a worse world, but a 1/4 degree of cooling would make for a better world, measurably better in either case?
Yeah, I mean, that's not very much either way. So
how about 1 degree either way? Let's go 1 degree Celsius.
Okay. So again, rate of change is a critical thing. 1 degree we've already done. If we just tomorrow plunged a degree cooler and stayed there, the oceans just somehow vaporized their heat. I have no idea what the consequences would be, but they probably would be better than it spontaneously gaining 1 degree. You look at something like coral. If you do the 1 degree cooling, suddenly we got an entire break and let coral recover, the right way, actual functional species. Whereas when we pop another 1 degree warming, they're toast. So
what do you think that would do to farming in Canada, for example, 1 degree Celsius of cooling?
Yeah. I mean, all these temperatures, I feel like that's an argument, from the concern side, is that, when you change climates, the crops that you grow is one of those factors that, they're significantly affected by rates of humidity, by typical peak temperatures in a year. And that's what studies show, is that that's already having a negative effect on what was the natural growth in crop yields. It's already, starting to slow that because, you're changing humidity and rain patterns. So I think making it a degree cooler, making it a degree warmer, either one really fast would screw up farming.
Okay, let's see. We're coming up to the end of our 90 minutes. I've really enjoyed this. Thanks for doing this.
I have as well, and thanks for letting me talk a bunch. I feel like I love the topic. I think it's interesting regardless of things. So I tend to talk. I appreciate you've been very, very patient with that, Tom. Thank you.
Sounds good. Okay, I think maybe we'll wrap up this one. Maybe we can do it again sometime. But thanks again for doing this, and we'll talk to you next time.
Okay, thanks very much, Tom. Have a great week.
You too. Talk to you soon. Goodbye.
Bye.